This is Mr. Kamotho and welcome to my YouTube channel, Maths with Ease. And I want us to learn how to prove cosine rule now that we have understood how to use it and we have used it in the previous videos as evidenced in the slides that you have been coming through. This video, I just want us to learn how to prove the cosine rule. Even if there's a note here, note, proof of cosine rule is not required by the specification, but it's okay. We need to know exactly what's happening. And you can see we have a triangle A, B, C. And if this is vertex A, this is side A, this is vertex B, the whole of this is side B, and this is C, this is side C. You can see that we have dropped a perpendicular height for the triangle at D, and that height is H, and that divides the side B into two portions, which we don't know whether they are equal or not. And because we don't know, we can take that portion to be X and this portion to be B minus X. And if we use triangle ABD and Pythagoras, we can already see that x squared plus h squared is equals to c squared. X squared plus h squared is equals to c squared. Again, if you use triangle BDC, we can see that b minus x squared plus h squared is equals to a squared. And at that point, we probably need to open this bracket, which is going to give us, let's see, this bracket, b squared minus 2bx plus x squared plus h squared is equals to a squared. And as you can see, from equation 1, we can at least make this one. We can make h squared the subject, and we can also make h squared the subject here, which is going to be, let's see, h squared is equals to c squared minus x squared. And as such, again here, h squared is equals to b squared is equals to is equal to a squared minus b squared plus 2bx minus x squared. And because we know these two are equal, we can call this equation 1, and we can have this one as equation 2. And because we know equation 1 is equals to equation 2, because both of them are talking about h squared, then we can easily have that this side, a squared minus b squared plus 2bx minus x squared is equals to c squared minus x squared. And as such, we would want now to talk of, let's probably try to make a squared the subject of the formula. But of course, you can see, so a squared is equals to, this one goes across, becomes b squared plus c squared, this and that. There is minus x squared. This one goes across plus x squared minus 2bx. There we are. So a squared is equals to all this now. Of course, minus x squared plus x squared will cancel out. And we are left with a squared is equals to b squared plus c squared minus 2bx. At that point, we realize that a is a side, b is a side, c is a side, and b is a side, and x is not a side. So we would want now to consider triangle ABD and establish what could that x be. Now, while we are here, we can already come here and talk about the triangle ABD and say the cosine of angle A, which is this one, using now the SOHCAHTOA, is given by the adjacent, which is x, over the hypotenuse, which happens to be c. That is it. So making x the subject of the formula, we have x is equals to c cosine A. So when we bring now this into the main picture here, then we are having a squared is equals to b squared plus c squared minus 2b, and then x is c cosine A. C cosine A. And that becomes now the cosine rule. Please note, it can be used to calculate any side. And let us go further and say, if we start with side A, we end with angle A. So we can also have b squared is equals to a squared plus c squared minus 2ac, the cosine of angle B. It can also be used that way. If you wish now to start with side C, we'll say c squared is equals to a squared plus b squared minus 2ab multiplied by the cosine of angle C. This cosine rule can be used to calculate any side, and to some extent is also going to be used to calculate the angles. In this sense, we can continue to have, for example, if we want to use now the first one, this one, the first one, we can make the side that is having the angle the subject of the formula. And we can easily say, if we take everything across, we can easily have 2bc cosine A is equals to b squared plus c squared minus a squared. And because we want to calculate the angle, of course, we divide both sides by 2bc, and we can see the cosine of angle A is b squared plus c squared minus a squared, everything over 2bc. And if you want to get the angle, it is now the cosine inverse of the whole of this. Whatever you find this to be, the cos inverse of this is equals to, is going to give you angle A in decrease. Angle A in decrease is going to give you angle A in decrease. And that is how you can work with all the others. Remember, if you are here and you want to calculate now the A, side A, you simply square root the whole of this other side, which is easy. And there you are. Thank you, and let us meet in the next video.